Hello and welcome to my lecture on the internet for Computer Science 1030 class, or for whatever class I might use this lecture for in the future. I can't tell the future any more than you have. But let's talk about the internet, which is the mother of all networks. Hopefully you have watched my last video on how networks work. Now we're going to apply all that information to how the internet works as the mother of all networks. First, just a little bit of history for you. The internet was first hypothesized as a theory or an idea by a CERN laboratory technician in the late 1980s. He realized that scientific research was growing at such a fast rate, growing so quickly, that the only way science could be efficient is if every scientist in the world had some sort of forum where they could post their research, and where those forums could be searched, so that if you were working on a project in one country and somebody was working on that same thing in another country, you could find out that each other exists and share your research and share your hypotheses and your studies and your conclusions. And so he put together this plan for this way that they could build this big network. I don't think in the late 1980s, him and his team had any idea that it would turn into what it has turned into. So if you take my other computer class, we talk a lot about the societal effects of the internet. One of my favorite quotes about the internet is that it's the greatest experiment in anarchy we've yet conducted as a human species, but that's another discussion for another time. This is just about how the internet works. And there's two things that make the internet work that were critical to even the original plan proposed in the late 1980s. One is everybody has an address. Every device has an address. Right now, as I am filming this lecture or recording this lecture, I'm recording it on a little HP laptop I just bought a week or two ago. Right sitting next to it is my tablet, my trusty tablet, which I carry around with me, and in my pocket is a cell phone. Each one of those three devices has an address, has a way that they can be found. It's just like a home address. We're going to talk more about that on the next slide. And an address gives every device a point of presence, and that's all run by the routers. A router, if you remember from the last lecture, is a hub, but it's a glorified hub that can manage multiple networks and can do way more than just switch things on and off, or transfer outputs to inputs and all of that, and amplify signals or whatever the repeaters did. It's just the router does everything. It's a repeater and a hub and a switch and a bridge all on steroids. And so everybody who is on the internet has a router, and the router gives every device an address by which it can be found. You guys probably already know that's called the IP address. And so if we wanted to, and if you look at the background image right here behind this with all those little dots all over the world map and then the lines, if we want to, we could actually create a map. It would be like a huge map, and almost I mean, the way you mapped it out, I mean, you'd have to zoom in, but we could create a map that mapped every device that's attached to the internet to every other device. Every device has a point in that map where it is connected to the network as a whole, and how that works is by addressing. So let me dig more into that. Addressing works that every nation is given its own number. It's given its own IP address, and so every nation has its own number. And so think binary numbers converted into decimal numbers. Think through that. And so every nation is given a binary number by which that nation can be found on the internet. And so I think the United States one is like 00, because we were kind of the first ones to do the internet. And so every nation has a number, and every nation has a backbone. which is a router, and those routers are ringed together at the top layer of the internet. And so whenever you send a request to a website or send an email or whatever you're doing on the internet, it goes all the way up to your national backbone provider if you're grabbing something from another nation. And so all those nation numbers are ringed together. And then every nation divides its sort of internet up into regions. Here in the United States, we only have two, a Western and an Eastern. A really fun thing, if you want to do it right now, if you're an international student, or even if you're a national student and just are curious, just Google regional ISPs of and a random country: Iraq, Afghanistan, Thailand, South Africa, Brazil, Chile, whatever, England, and it will tell you how many regions that your country has, or that country has. So the United States only has two. We have West and we have East, and that's another portion of the number. By the way, it's ISP, stands for Internet Service Provider. So we have a regional provider that provides the internet to us, provides internet service to us, so Internet Service Provider. And then the region hands it down to a local internet service provider. So there are companies. This is where the United States hands it over to companies. They hand it over to CenturyLink. Right now I have Utopia Internet, so Utopia has a ISP number, and then there's also Comcast here in Utah, so Comcast has another portion of that number. And then when I want internet, I call one of those companies, and they give me a router, and that router has another number, which is the address of my home. And so it just works just like my home address. My home address is, well, we'll take the school's address. It's 2356 US 189. So obviously 2356 is where the school actually is, but it's on the road. And then the road is in a city, Layton, and this city is in a state, Utah, and the state is in a country, USA. And so your internet works the same way. Your router, whatever router is giving you the internet right now, has a number, and then that router creates a route to, is routed to a local company, which is then routed to the regional western side of the United States, which then goes up to our national backbone, which in turn is connected to all the other national backbones of all the countries around the world, and that's how it works. So when you load a web page, when you go online, when you came on Canvas, or however I'm distributing this video, YouTube, whatever, the first thing that was transmitted through that network was your address. It said the device at this router, which is connected to this local ISP, which is connected to this regional ISP, which is connected to the United States backbone, if you're in the US or wherever country you're in, needs this website or this email or this song or this whatever from this ISP, from this company, from wherever this information is stored. So your IP address is how the internet works. And if you if you think your information can't be tracked, you're wrong. Like, this is how the government tracks information on the internet to see if anything bad is happening, because the very first thing transmitted is the address. So how IP hiders work is they try to route it through another country, so at least there's a break in the chain, but that also creates a flag. If you're connecting to like a Russian, if you're connecting through a Russian national backbone or regional ISP, then the US government flags that and says this person may have been accessing information, and they look for it as it comes back through, because they have to send it back through. And so it's important for you to know you can't ever really hide it, because it's just that's just the way the internet works. To hide your IP address is to mean you can't access any websites on the internet. So be careful what you're looking at, all that to say, but that's how the internet works. And the routers themselves are the ones that provide the address. That's where the addresses are provided and stored. So let's talk about the internet protocols that make the internet work. Last week we talked about protocols, and we talked about the 7 things you have to think through when you're building a network. You have to think through your physical connection. You have to think through the data link connection, how you're going to divide the information up into manageable chunks to send across the network, and how you're going to do addresses in that. You have to map a way across your network. You have to set up a session between 2 devices, present and interpret the data, and apply it, right? So these are the protocols that make all that work. So first of all, HTTP is a hypertext transfer protocol. That's sort of your data link protocol. And so the internet works because every single browser is programmed to interpret HTTP. And so HTTP transfers hypertext. There's going to be another lecture in this unit if you're in my CS 1030 class, which that teaches you a little bit of HTML coding. HTML is a hypertext markup language. That's pretty much all the internet does, although it can send other files. Your email protocol is a little bit different. It's simple file transfer email, so it's a little bit of a different protocol, but they do the same thing. They divide the message up into manageable chunks and get it across your network. And then you have a file transfer protocol. That's if you're sending an image file, or if you're sending a song or a movie, an MP4 file, that's a different protocol. And then you have your TCP/IP protocols, which they are actually responsible for the bulk of the internet. They're responsible for setting up the session, for doing the addressing and all of that. So, so these are your protocols that make the internet work. Don't worry too much about these. Just what I want you to see is this, how your 7 layers of the ISO are on the left, and then on the right is the internet protocols that line up with these. And so obviously the physical link is whatever you're using to access the internet. If you're using a modem cord, if you're using Wi-Fi, if you're using 4G or 5G, you know, whatever you're using, you know, the internet can come through any physical link. And so, but your data link is your MAC and a little bit of your IP. Your IP, this is why we call it an IP address, by the way. Your IP address is the protocol, the internet protocol that gives you, your device, the address and keeps track of the addresses. In the early days of the internet, you actually had a human or a very simple computer program that assigned the addresses. Once we got up to billions of people using the internet, there was no way to keep up with all that. So right now, the routers just assign you an IP randomly. So that's a huge part of the IP protocol, is they just randomly give everybody a number. It's just a random number generator. So your IP address is just generated randomly. To a point, obviously. And so your MAC protocol right above IP there is what divides up the HTML into the manageable chunks and sends it over. Every website is divided into the same amount of chunks and sends it over. And then you have your TCP protocol, which IP and TCP work together. The TCP is what keeps track of the points of presence, keeps track of where every device is on the internet and how they're all connected together, so that the TCP can map the way and transport it across the internet. Your TCP also does something else very interesting, and that is it has what's called a TTL, which is time to live, TTL. And TTL, time to live, means that it tries several different times to get the website across the internet to the device that requested it. And it starts with a number. It starts with a binary number. Remember, everything's binary. It starts with a binary number, and then every time it fails, it subtracts 1 off that number. And if that number hits 0, and so that means it's tried, if it's set to 10 and it tries 10 times, then when it hits 0, then you get an error message that says file not found, or we couldn't do it, or sorry. So that's what TCP does. It has a number, and then it tries several different ways across the internet, and if it fails, it comes back and says we couldn't do it, try again. And so that's how time to live works. Telnet is the way we set up the session between the 2 devices. And then HTTP, which I already talked about, is what presents the data. If everything is formatted into hypertext, then it works. If not, you have to work the file transfer protocol, which is down there. So HTTP, SMTP, and FTP are all part of the presentation application layers. They're just different ways, they're different formats of getting files across the internet. And so, yeah. So that's how, those are the ways the internet protocols line up with the ISO protocols. You have a physical link, whatever it is. It can be many things that we talked about last week. Then you have the MAC protocol, which divides it up into manageable chunks and keeps track of those. Then you have IP, which does a little bit of the data link. It keeps track of everybody's addresses, assigns everybody an address, an IP address. TCP gets it across the network and transports it and lets you know if time to live hits 0, it lets you know we couldn't do it. Telnet sets up the sessions between the devices, and then the HTTP, SMTP, FTP are different ways of presenting and applying the data. So yeah, that's how the internet works. Very easy. Remember, this is an introductory class, so you'll take classes, if you go to get a computer degree, you'll take classes that dig much deeper into these things. I'm just giving you the broad strokes. So, So let's talk a little bit more about IP. Your IP address is usually a 32-bit number, usually assigned to a router, so that's your street name. I kind of already talked about this. The router addresses to devices, which would be your street number. So if I connect to a new Wi-Fi network, that router gives my device a new number that it uses for however long I'm connected to that device. And then DHCP is the protocol that gives everybody a random IP number. Remember, I said IP numbers are assigned randomly by the router. That's called DHCP. That's kind of an important thing. So the big thing is to understand is the routers are the thing that makes the internet work. The router, without routers, the internet doesn't work. Without everybody having a device called a router, which keeps track of all the IP numbers, which keeps track of all the connections between all the computers and keeps track of the addresses and knows where to send it, you don't have an internet. So without these routers at every level, then you don't know what you're doing. So obviously URLs, that's your website, are just words assigned to your IPs. And so it's really hard to remember, obviously, that 10010010011100110 gets you to Google, right? Especially if one little 1 or 0 in there gets you to Apple's website. All right, so what they did with the URLs, which was really cool, is that they basically assigned a word to an IP. And so every IP address actually has words that you can assign to it. You have to pay money for that. And how URLs work is the protocol is the first thing. That's why every website begins with HTTP:// That's your protocol. That's, hey, this is the protocol I'm using. Here's the protocol I want to use to transfer the information. It's the hypertext protocol is what transfers HTML, which is what every website is. So I'm going to use the HTML protocol. And then you do the host name, the network name, and a folder and a file. So lcaeagles.com is our host name. That's who's hosting this website. That's who owns this website. They're where the website lives. It's host. Com just stands for commercial. You also have org for organization. You also have net for network sort of website. You also have edu for an educational website. So you have several different networks right there, and so several different mini networks in the big internet network. And then the folder is calendar and the file is school. Just like on your machine, you have folders and files. Just like in any desk, you have folders and files and filing cabinets. And so that's how URLs work. But you have the routers. Just keep track and know that if lcaeagles.com comes through, your router memorizes what binary number that is. It knows where to find lcaeagles.com, and so it just assigns a binary number to that, and there's a big massive database somewhere that keeps track of all that, and it's saved in every router, which is kind of crazy. So that's how URLs work. We're just assigning words to the IPs and beginning with what protocol we're using. So we're transferring this with hypertext. Email is a little bit of a different story. Email uses the simple file transfer. So we begin that with whatever that was, SFTP, I think, or FTP. So that's how URLs work. And yeah, that's how the internet works. So kind of a crazy thing. If you understood protocols, you kind of understand it. If you're struggling with protocols, hopefully this helped you figure it out more. So the important things to know is every single internet provider has an address. Every single device has an address, sorry. Those addresses are tracked by routers. The router is the heart of the internet. That's definitely going to be on the quiz. IP and TCP are what keeps track of the addresses and keeps track of the transport and getting the files to where they need to go and the error stuff. And then URLs are just words assigned to your IP address. So easy peasy, right? Not really, but hopefully I've at least let you know enough to whet your appetite to learn more. So yeah, so if you have any questions, let me know. The internet's an amazing thing, isn't it?